Okay, so we've got the data. We're ready to do some analysis. So I wanted to show you a little bit of how we're going to do that. So I've got Vernier Graphical Analysis open and I've downloaded the data file. So I'm going to go here to Choose File, and there's my file, and it's going to open up. And when it opens up, it's going to, mine went to the data table. I go to a graph. You'll notice that there's already one different column calculated here, and that is what I call angular velocity magnitude. We're taking the magnitude because you may have noticed in that video the way I secured the sensor to the wheels, it wasn't perfectly straight, and so we actually have a little bit of angular velocity that got picked up in all three axes, the X, Y, and Z. But if we take the magnitude, that'll actually tell us how fast the wheel was rotating, because that's the only way it was rotating. So that's what we want to look at. For this, I'm going to need you to do a couple of things. One of them is to look at the angular velocity and use that to calculate the distance traveled. I also want you to plot the velocity and acceleration for a point on the edge of the tire. So to do that, you're going to have to come up here, switch over to a table view, and come down here and add a calculated column. So you'll say calculated column 1. Let's say we wanted to calculate our velocity, or more precisely our speed. Its units would be meters per second. And then we come down here and click Insert Expression. And we would choose the mathematical expression that we think would relate our speed to the angular velocity that we measured. So in this case, A, B, and C are going to be constants that you can set. X, Y, and Z are going to be columns in our data table. So let's suppose I think that the relationship between angular velocity and regular velocity is going to look like a sum constant times the natural log of my angular velocity. That's obviously wrong, but let's just assume it. So I do that. I come down here. I say, let's say I think this parameter needs to be the radius squared, or the radius we'll just do. So 0.29 meters times the natural log of my thing. I hit apply. And voila, I've got this new column over here. Now I can come back to my graph and it's already plotting speed. So it thinks I was going negative half a meter per second, and then I sped up a little bit, and that's what my speed looked like. Now, just to be clear, that's not right. Obviously, half a meter, or the natural log, is not what you want to be doing here. But you'll need to look at that and figure out how to use that to get your velocity as well. Okay, have fun.